You guys, I got some results for those of you that took the paper that I have to hand out too. Okay, guys, we're gonna go over the rest of section 6.2 today, and the first thing we're gonna learn is something called compound interest. So when you have your money in savings, there's two different types of interest in a savings account. One is called simple interest, and one is called compound interest. Compound interest gives you a lot more interest paid on your money, but not all savings accounts, maybe not any, I'm not positive on that, give compound interest. But when you, certain things, like when you get a CD, if you put your money into that, that can have compound interest. And they'll always tell you different ways that money is compounded. And I put the different ones over here. So when you have compound interest, it could be compounded just once a year, which is annually. And you'll see here, I have a value for N. When it's annually, the N is here and here. You would put 1 in for each of those. Semi-annually means twice a year, so N is 2. Quarterly means 4 times a year. Monthly, 12 months a year. Bi-monthly is every other month, so that's 6. Weekly is 52. Bi-weekly is 26, which is every other week, okay? So with compound interest, you're going to have that exponential function again. And your interest would be paid on what you put into the investment and any previously earned interest that you've earned, okay? So this formula, if you learn how to put it into your calculator correctly, it's not super easy to do, but if you learn how to do it that way, then you can just punch it in exactly how it looks, but you do have to be a little bit careful with parentheses. But this is our formula. A is what you would have at the end of your savings or your CD being compounded interest. P is what you put in at the beginning. R is your rate as a decimal. N again comes from this, and I did put this on your cheat sheet. And then this N and that N are the same, and T is typically how many years you have that money in that CD for whatever it is that you have. So here it says an investment pays a 4.2% annual interest compounded quarterly. Okay. So when we do these, I always write off to the side, what is my P? What is my R? What is my N? And what is my T? Okay. P is how much money you put into the account. Okay. Which is $2,500. R is your percent, 4.2 as a decimal. So we move that over 2 places and it's 0.042. And if it's quarterly, that just means you're getting it 4 times a year. So N is 4. And then T is how many years. And they want to know how much would you have after 15 years. So T is 15. Okay, so now what we're going to do is go and put all that into our formula here. So P is 2,500. And then it's 1 plus R divided by N, which is 0.042. Divided by N, which is 4. And that is all to the N times T power. So it's to the 4 times 15 power. Okay. Now, like I said, there's 2 ways you could do this. One way is you could simplify this and then keep track of that. You could multiply that, keep track of that, and then redo the equation, putting in a different number for this and 60 for that, and then type it in. And you wouldn't have to worry so much about parentheses. So you certainly could do that. Another way you could do this, I'll take you to the calculator and I'll show you, but I have to explain this. To do this, you have to put parentheses on both sides of this. So you're going to have to put a parenthesis before it and after it. Okay. So you basically are going to have two parentheses in a row here. This one is to close out this parenthesis, and then the purple one is to close out that parenthesis. Then you're going to do your up arrow. And when you do 4 times 15, if you have the color edition one, the CE version, you should not have to do parentheses for this. But I believe if you have an older one, then you do have to do parentheses around that. So let's go ahead and try to do that. Okay. So we're going to go 2,500 parentheses. And then we're going to go 1 plus. Now we want parentheses around the 0.042 divided by 4. So we're going to go parenthesis 0.042 divided by 4 parentheses. Okay. And you have to remember this parenthesis closes this. I need one more to close this. So I need a second parenthesis there. Now I can use my up arrow and take it to that power. So I'm going to go up arrow. Now this one's a CE version of the TI calculator, and so is your MacBook. So you should not need parentheses here, but if you have an older version, then you do. So I'll do it with parentheses just for those of you that have to. So you would just go parentheses 4 times 15 parentheses. Okay. And then hit enter. And is that what you guys got? Is that too hard for you to remember how to type in? Do you want me to show you the other way too? You're okay with this? All right, so let's go back here. All right, so we got, and this is money, so $4,678.63. If you did it the other way, and you calculated this and then put it to the 60th power, because you didn't want to use all the parentheses, your answer would be a little bit off from ours because yours wouldn't be as accurate. The way we're doing it, we're not rounding at all. So that's why yours would be off a little. So if I look at this one, it says, again, you want to know what is my P, R, N, and T. Okay, P is how much money I put in, which is $2,000. And this one, it has 4% annual interest, and if you move the decimal over, it's 0.04. How much money is in the account after 5 years? So T is 5. And then they give us two different situations. One is when the interest is compounded bi-weekly, and bi-weekly is every other week. So that's 26 times a year. So let's go ahead and put that in. So we have A equals P is 2,000. And then that's 1 plus R is 0.04 divided by 26. All to the 26 times 5 power. Okay. Big thing you have to remember is you're going to have a parenthesis here and a parenthesis here. And if you have an older calculator, you're going to do parentheses there. Okay. Alex, did you have to use parentheses here? Yeah, I think so. Does anyone have like one of the silver ones? Do you have to, Emma, do you have to use the parentheses? Yeah. Okay. So I'm not sure on the one Emma has, but I think on the one Alex has, you have to use the parentheses. Okay, so let's do that. We'd have 2,000. And then we would go parenthesis 1 plus, and we need that 0.04 over 26 in parentheses. Okay, and then I need a second parenthesis after that. Don't forget about that. Then we're going to go up arrow, and if you have one that you need that in parentheses, you'd go parenthesis, and then it would be 26 times 5. Okay, did you guys get $2,442.43? So if I put that answer here, $2,442.43. Okay. Then when you do it monthly, this all is going to stay the same, except our N is going to be 12 when it's monthly. So this would be 2,000. And then it would be 1 plus, R is still 0.04. And this time is 12. And then this is to the 12 times 5. Okay. I will show you guys a little trick on a graphing calculator that you can do. You have to type in the same exact thing and just change 1 or 2 things. You can like call this whole thing down and then edit it. And how you do that is if you go second and enter, there's this entry above it. So if you go second enter, notice it brought this whole thing down. And the only things that I need to change here are I need to change the 26 to 12. So I can just do my back arrow and change this 26 to 12. And then this 26 to 12. And then if I just hit enter again, then I just didn't have to retype it all. Okay, so that one, did you guys get 2,441.99? Okay. So $2,441.99. So you're gonna notice, like, if you have a small amount of money in an account, which actually for investments, $2,000 is kind of small, and at 4% annual interest rate, notice if it's compounded 26 times versus 12 times in 5 years, it really doesn't make that much difference. But if you had 100,000 in there and at a 10%, then it could make a much bigger difference. Okay, especially if it's a retirement account and it's like when we put money in for retirement, we keep it in there for years until we retire. That can make a big difference then. Okay, so if we look at this, the last thing that we are going to do is exactly what we did yesterday, except these problems are inequalities, so they have a greater than or less than sign. Otherwise, we do it the same way as we did yesterday. So if you remember what we did yesterday, we try to get the 10 and the 1,000 to the same base. And if I look down here at my powers of 10, I have 10, and 10 to the third power is 1,000. So that's what I'm going to use. Okay. So this is just going to be 10 to the 5b plus 2. I leave that sign, and this is 10 to the third power. Now we have them both to the same base. So if you remember from yesterday, when you have them to the same base, it's like you can ignore that base and just say 5b plus 2 is greater than 3, and then you're going to solve it. Okay. So what I'm going to do here is I'm going to subtract 2. Okay, and I get 5b is greater than 3 minus 2 is 1. Then I'm going to divide by 5, and b is greater than 1/5. I could leave it as, or if I divided that, it would be 0.2. And that is your answer. When you are doing inequalities and solving them, the only thing you have to do different is if you multiply or divide by a negative. If this were a -5, you have to switch your sign. That's the only difference. Okay. So if we look down here, this kind of looks like -625, but this is less than or equal to, so that's not a negative. It kind of looks that way. With 5 and 625, if I go here, here's my 5, and here's 625. So I want to get them to 5 and 5 to the 4th power. So I can leave this one as 5. And then this is 1/5 to the 4th. And when you do that, you could have kind of saved this step. And do you guys get when you bring this to the top, it's going to be 5 to the -4th? Everybody understand that? Okay. Now they're to that same base. So we forget about the base. And we have 3 minus 2x is less than or equal to -4. And then we solve that. So I have my x here. I'm going to bring the 3 over by subtracting it. And then I have -2x is less than or equal to -7. And then I have to get rid of this -2, so I divide by a -2. And when you divide by a negative, what do you have to remember? You have to change the sign. And a -7 over -2, the negatives cancel. And you could write this as 7/2. Or if you just went on your calculator and went -7 divided by -2, it's 3.5. And either way is fine to do. Okay. And if we look at this one, notice we have 9 and 27. So, 9 and 27, 9 is 3 squared, 27 is 3 cubed. So here's what we're gonna do here. The 9 is 1 over 3 squared. And that's to the 2x plus 7, and then it's less than or equal to. 27 is 3 to the 3rd power, and then that is to the 6x minus 12. Okay. If I want to bring this to the top, which I have to, it's going to be 3 to the -2nd. And then I have to multiply that by 2x plus 7. And then over here, I have to multiply the 3 by the 6x minus 12. Okay. Now I'm going to distribute on both sides. So I'd get, well, actually, you know what? I can distribute and get rid of the 3's at the same time. So as I bring this down and get rid of my 3's, I'm going to distribute. -2 times 2x is -4x. -2 times 7 is -14. Here, when I distribute, 3 times 6x is 18x. 3 times a -12 is -36. Okay. Now, this part is super important. When I taught this earlier this year with some of you, and I know some of you had Mrs. Deering, I think in the fall, I showed always bringing your x's to the left, because what I found kids do, if you leave it here, and I can show leaving it there, but it's hard to graph when you leave the x over here because you have to read it this way. Okay, and I can do that. I can show you because some kids do this. We could bring this over. Okay, and we'd get -14 is less than or equal to, this is 22x minus 36. Okay, so now I have my x here, so I bring my numbers over here. So I would add 36. And I would get -14 plus 36 is 22. And then this is 22x. If I divide by 22 on both sides, on the left would be my 1. On the right, these would cancel and I'd have an x. And if you leave your answer like that, it's not wrong. But in the fall, we had to graph that. And so many kids went to 1 and they looked at this as less than, and they shaded this way, and that's wrong. When you have the x on the right-hand side, you have to read it that way. And so when you read it that way, it's really x is greater than or equal to 1. We don't have to shade them today, so it's okay if you have your x over here. I'm just saying that if you ever have to shade it, be careful of that. Do you want me to show you the other way too? Okay, good. Okay. Now, let's look at this one, 243 and 27. 243 and 27. Here's 243, 3 to the 5th, 27 is 3 to the 3rd. 3 to the 5th. And that is the 3x minus 2. And then 1/27 would be 1/3 cubed, and that's to the 2x plus 1. Okay, so this is 3 to the -5th, and you have to multiply that by 3x minus 2. This is 3 to the -3rd, and you have to multiply that by 2x plus 1. Okay, so on top we have -5 times 3x. Oh, no, I'm distributing, sorry. Let's distribute that. -5 times 3x is -15x. -5 times -2 is plus 10. And then here I'm going to distribute. -3 times 2x is -6x. -3 times 1 is -3. Okay. Now, when I do these, regardless what my x's are, I just always bring my x's to the left and I always bring my numbers to the right. Okay. I would bring this over, even though it's going to give us a negative number. So I'm going to add 6x. -15x plus 6x is -9x plus 10 is greater than a -3. And of course, I only bring my x over that side because it's an inequality. With an inequality, I like the x on the left. Now I'm going to subtract 10. And I get -9x is greater than -13. And then I divide by a -9. And hopefully you'd know then instead of this, you'd go less than, and then it would be 13/9. Okay. You could leave that as 13/9, or you could divide it and it would be 1 point something. Either of those would be absolutely fine. You have a worksheet. I think there's 10. Yeah. And I'll be making it as you guys are.